In mid-December of 1972, Eugene Cernan and Harrison Smith fired up the ascent engine on the Lunar Excursion module, and for the final time, humans left the lunar surface. To this day, the moon remains the furthest humans have travelled in the universe. But how far will we go in the future, and why? The why is a good place to start. We've always been explorers, and it's been imperative to our survival and how we've thrived as a species. Our particular brand of hominids outlasted the others because we went everywhere on Earth. As you can see from this diagram, we were the only species to go to every continent. The others found one place and stayed, often because they found sustainability, at least in the short term, but eventually they went extinct because they were confined to one place, making it easy for disease and famine and the like to wipe them out. And this was no such concern for us. We were everywhere, so small-scale extinction events were no threat to us. But now we have run out of places to go. A planetary extinction event is a real threat, be it a massive asteroid, nuclear winter, or the sun stripping our planet into an arid, irradiated wasteland. So we have run out of planet, but we have not run out of planets. If we are to endure for the long term, we need to become a multi-planet species. So these days, we look to space. People have been going to space for over 50 years now. The furthest a human has gone is to the moon, and the longest they stayed there was a little over 3 days, on the aforementioned Apollo 17, crewed by Eugene Cernan and Harrison Smith, while Ronald Evans remained in orbit of the moon. But that's not the longest we've stayed in space for. We have orbiting stations these days, and in 1995, Valery Polyakov completed a 438-day mission on the Mir space station. And last year, NASA astronaut Scott Kelly and Russian cosmonaut Mikhail Korniyenko launched aboard a Soyuz spacecraft to spend almost a year on the International Space Station. But neither of these are sustainable. Between the 3 days on the moon and the year on a space station which is essentially still at Earth and requires constant resupply. And surely the ultimate goal is to be able to stay wherever we go if we so choose. In addition to this, the further we go, the longer we'll have to stay in space anyway, so durability is important for exploring space. Today we look to Mars, our closest planet. From the outside, Mars looks pretty unhospitable, but it is the best candidate for a new home. The surface temperature sometimes rises as high as 20 degrees centigrade, or 68 degrees Fahrenheit. However, it averages around negative 55 degrees centigrade and negative 67 degrees Fahrenheit. But with well-insulated bases and eventual terraforming, it would be a rather hospitable place to live. Since the cancellation of the NASA Ares program, a story for another day, but basically a multi-step program for going to Mars involving things like a moon base, NASA has been working on the Orion program, a program that involves a brand new space capsule and a heavy lift rocket, the Space Launch System, with a payload to orbit capability of 70 metric tons. This will take astronauts into orbit of the moon and eventually to an asteroid, most likely placed in orbit of the moon. This is supposed to build the groundwork for a journey to Mars. Using an upgraded SLS, which will be the heaviest lifting rocket ever built, taking 120 metric tons of payload to orbit, they will be able to build vehicles for transferring to Mars. Elon Musk also has his sights set on the Red Planet. His company SpaceX is working on reusable rockets to make not just a mission affordable, but migration possible. He believes that we will one day be able to have a self-sustaining civilization on Mars, thus truly making us a multi-planet species. In addition, SpaceX recently announced plans to launch uncrewed Dragon 2 spacecraft to Mars for research purposes as early as 2018, although it has to be said that Mr. Musk has been known to be a little optimistic with deadlines. Mars, however, is problematic for two big reasons. While on the way to Mars, or any planet for that matter, you will be exposed to solar radiation on a major level. On Earth, we are protected by the Earth's magnetic field and the atmosphere. In a spacecraft exposed to the sun, the radiation could seriously increase the risk of cancer. Not only this, if a solar flare were to pass the spacecraft, it could very quickly kill the crew, due to extremely intense radiation. This can be lessened in a number of ways, such as placing all of the ship's water on one side pointed towards the sun, and potentially having lead-encased beds, since this would not be as costly as surrounding the whole ship in heavy lead, but it would reduce exposure to radiation for 8 hours out of the day. In the case of solar flares, having a place in the center of the ship surrounded by all of the equipment could potentially reduce the danger from solar flares significantly. In addition, Mars is still very inhospitable. If you were to leave your spacecraft or artificial habitat, you would have to wear a spacesuit, which really limits maneuverability. But there is potential to terraform Mars by pumping CO2 into the atmosphere to heat up the atmosphere, much the same as we do on Earth right now, but in a good way. This would heat up the planet and increase the atmospheric pressure so that you could walk on Mars with just an oxygen mask. And introducing plant life that would turn CO2 into oxygen, we could eventually live on Mars as we do on Earth. But ultimately, Mars will go the same way as Earth, be it an asteroid impact or being swallowed up by the expanding sun. As with our planets, our solar system will not last forever, so we must go further, to the stars. So how do you get to other stars? Well, we already have spacecraft heading out into the cosmos. Many of the probes we have sent to explore the outer planets reached escape velocity due to massive gravity assists they received from the gas giants. The first spacecraft to reach solar escape velocity and ultimately leave the solar system was Pioneer 10, followed by Pioneer 11, after flying past Jupiter and Saturn respectively. Voyager 1 and 2 were later sent to swing by our outer planets and to ultimately leave our solar system as well. Pioneer 11 is ultimately destined to pass near a star in the Sagittarius constellation in 4 million years. However, there are stars nearer to us, and using conventional rocket technology, we could potentially get to Proxima Centauri in 30,000 years. So conventional rockets can't effectively take us beyond our solar system. But what if we could get there faster? Is there a way? Well, maybe. The most promising technology right now is lasers and light sails. You may have heard the recent rumblings in the scientific community about Stephen Hawking, Yuri Milner, and their plan to create tiny interstellar probes that use this technology. But how does this work? Well, while photons are massless, they do exert an impulse. So you can move things with light, and it's been done using solar sails, which use the sun's radiation to push on large sails for effectively free change in velocity. But this is very slow and only applies a tiny force. This can be improved by replacing the use of the sun with lasers. Theoretically, a large array of high-powered lasers on the surface of Earth could be used to push on a big solar sail attached to a tiny spacecraft, around 1 gram in mass, effectively just a tiny CPU. And if we can scale down other equipment such as cameras and communications equipment, this could be a viable spacecraft. Anyway, this method could potentially accelerate the tiny spacecraft to 20% of the speed of light, orders of magnitude faster than Voyager 1. This could make a mission to Alpha Centauri, which is 4.3 light years away, possible in just 20 years, a little over double the time it took New Horizons to get to Pluto. This does, however, have its problems. It relies on effective probes being able to be miniaturized to this scale and relies on significant improvements in laser technology, which are a big but. So we may be waiting a while. But you may be asking, what about warp drive? People on Star Trek seem to have it pretty easy getting around, right? Well, there are actually people looking into this. One of the major warp drive ideas is the Alcubierre drive, a system proposed by theoretical physicist Miguel Alcubierre that effectively warps space to achieve relative faster-than-light travel. How does it do this? Well, that's quite complicated and a subject for another day, but in essence it would create an energy density field lower than that of a vacuum, which would effectively create negative mass. This would allow it to contract space in front of it and expand space behind it, hence warping space, allowing it to travel faster than light relative to us and the stars, while not travelling faster than light in its own reference frame, and thus not violating the laws of physics. But that all depends on if you can actually create negative mass, and if, in reality, any of this would have any meaningful effect. But there are people actually working on this, at least at the theoretical level. I guess finally we could talk about intergalactic travel. This, however, seems like a reach, since other galaxies are even further away, and we have around 100 billion stars in the Milky Way, at least some of which will hopefully be hospitable. In addition, the universe is expanding, so the other galaxies are leaving us, and one day won't even be visible in the night sky anymore. On a side note, our closest galaxy, Andromeda, is actually moving towards us, and will eventually collide with the Milky Way in 4 billion years, giving us a far more interesting night sky. But don't worry, we'll be fine on a planetary level. It's very unlikely that the solar system would be torn apart. But anyway, other than the galaxies coming to us, it seems very unlikely that we'll ever visit another galaxy. So what does this all mean? Well, for longevity as a species to be achieved, we need to become a multi-planet species, and eventually a multi-star species. Using the lessons learned from the Moon and the International Space Station, we are working on promising ways to go to and maybe even stay on our closest planet, and there are ideas for going even further. But I think something that is also worth mentioning is that this isn't just some large-scale life insurance plan. We didn't start exploring at the dawn of man because we knew we'd do best by doing so. The need to explore is inherent in all of us, and to quote Elon Musk, a future where we are out exploring the stars is far more exciting and inspiring than one where we're forever confined to Earth. As a final point about what we've already achieved, while sending interstellar probes may not save us from destruction, all of these spacecraft carry a little piece of us, be it the golden records with the sounds of Earth on Voyager, or the diagram trying to describe what we look like and where we are on Pioneer. Since if we are forever confined to Earth and suffer some eventual extinction event, these probes will endure forever, so that if they are ever found, there will be a sign that we were here. Hey guys, I really hope you enjoyed that. I know it's something totally different to what I usually do. I'm a gaming channel, if you don't know. But, you know, I really wanted to talk about this sort of thing, and I didn't really know how to do it. I'm not much of a vlogger. So I thought I'd put together this sort of thing. I'm not much of an animator either, as you can probably tell. But yeah, I hope you've enjoyed this, and I just thought I'd put this in at the end, just to be like, for the people who are like, wait, what? So yeah, if you did like it though, leave it a like and tell me you liked it, because I would love to do more of this sort of stuff in the future, and maybe my animations and making images fade skills will be better. So yeah, I'll see you next time.